Today let's discuss the current divider rule. Now first let's go over some basics. And the relationship between current and resistance is inversely proportional. So current is inversely proportional to the resistance. Now what that means is that when the resistance increases, the current will decrease. And again, when the resistance decreases, the current will increase. And the current will always seek the path of least resistance. So if we have two pathways in the circuit, say one path has 5 ohm resistance and the other path has, let's say, 2 ohm resistance, okay, and the current has a choice here. It's a fork. The current comes from here. Now this is a fork. Which direction will the current go? Most of the current will go through the 2 ohm resistance because this is the path of least resistance, and a little amount of current will go through 5 ohm, but the major part of the current will go through the 2 ohm resistance. This is current's nature. It always seeks the path of least resistance. Current is kind of lazy, so it goes through the path that has the least effort, that needs the least effort. And for parallel resistors, the current will divide as the inverse of their resistor values. So and that is actually expressed in the form of an equation which goes as such: I1 over I2 is equal to R2 over R1. I1. So I1 over I2 is equal to R2 over R1. Now be careful, it's I1 over I2 and then R2 is on top, so R2 over R1. And from this equation we can find the current divider rule. The current divider rule is derived from this equation. Now let's actually start with the current divider formula. From the Ohm's law, we know that Ohm's law is I is equal to V over R, right? So if we want the current of a specific resistance, then Ix, say resistor X, then Ix is equal to V, or the voltage flowing through that resistor, the voltage for that resistor or flowing through that resistor, over Rx, so the resistance of that resistor. That's what you have here. So Ix equal to V over Rx. Now the comprehensive current divider formula is Ix is equal to RT. You can write RT, so the total resistance, over Rx, that specific resistance through which the current we are finding, times IT, so the total current. It's usually written as I capital T. RT and IT. Now what does this current divider formula come from? From that ratio equation. So we had I1 over I2 is equal to R2 over R1. Now if you consider that I1 is the resistance, is the current, a specific current we want to find, the current flowing through a specific resistor, then, and I2 we consider it to be the total current. Basically 1 is equal to specific, and 2 is equal to total. So R2 is total resistance and R1 is the specific resistance of that of the resistor the current we are trying to find. So I1 is equal to, if we rearrange this, it will be I1 is equal to R2 over R1 times IT. IT will be I2 in this case, so it's the same as this one. That's how we get the current divider formula. And the sum of all individual currents through parallel components will always be equal to the total current. Now notice it's parallel, so this works only for parallel, not series circuits, only for parallel circuits. And what this basically means is IT is equal to I1 plus I2 plus I3 plus dash dash dash. but this works only for the parallel circuits, not series circuits. Same as for voltage divider, this worked only for current series circuits, not parallel. So VT was equal to V1 plus V2 plus V3, but only for series. This is only parallel, and this was only series. Now let's go to some practice questions. So we have a simple parallel circuit here. Again, how do we know they are parallel circuits? R1 and R2 have two common points, one here and one here. Now we have to find IR1, which means the current flowing through R1, and IR2, which means the current flowing through R2. So this and this. Now let's apply the, let's go back to the formula here. So we have RT over Rx. That means we have to find RT first. And also IT. So we have to find RT and IT. Let's write the formula here. So Ix is equal to RT over Rx times IT. Now what is Rx for us? So Rx using the equivalent, no, RT. So RT using the equivalent resistance formula for parallel circuits will be 1 over R1, so 1 over 9, plus 1 over R2, so 1 over 18. And enclose them in brackets and to the power minus 1. And that equals to 6. Now, what's IT? So IT will be the total voltage, so E, so 27 volts over RT, so that is 6 ohms. Is equal to 27 divided by 6, that's 4.5. 4.5 amperes, and this was ohms. Now what is IR1? Let's go to a new page. Now IR1 is equal to R2, so total resistance, that was 6 ohms for us. 6 over the resistance of R1. R1 was 9 ohms. So 9 times IT, which was 4.5 amperes. So times 4.5. And that equals to 6 over 9 times 4.5, 3 ohms, 3 amperes. So IR1 is 3 amperes. That's our first answer. Now IR2 is equal to, again, total resistance, so 6 on the top, and in the denominator is R2 is 18 ohms. So 18 times, again, IT, so 4.5 is equal to 6 over 18 times 4.5. That's 1.5 amperes. 1.5 amperes. That's our second answer. Let's move on to another question. Now this is a mixed circuit. We have series connections. We have many parallel connections. Now we have to find the current through the 10 ohm resistor. Now notice that this 2 ohm resistance and 10 ohm resistor, they are in series. So, and in series we do not, the current divider doesn't work. So the current through all the series resistors will be the same. So for finding the resistor, the current through 10 ohm, we have to find the current through the 2 and 10 ohms in series. So basically the current of this branch. Now how do we do that? Again, let's write down the formula. Ix is equal to RT over Rx times IT. Right? Now what's RT? RT here is 1 over 5 plus 1 over 4 plus 1 over 3 plus 1 plus 1 over 2 plus 10, so 12. Again, these two are in series, so we're counting them as one branch. So 2 plus 10 series, to the power minus 1, and that equals to 1 over 5 plus 1 over 4 plus 1 over 3 plus 1 plus 1 over 12 to the power minus 1. That is 0.54. So 0.54 ohms. Let's go to a new page. So we have RT, now we need IT. IT will be 30 volts, so E30 over RT, that is 0.54. We have 30 over 0.54, that's 55.56. So 55.56 amperes. Now what about Rx? Again, remember this 2 ohm and 10 ohm are a single series branch. So for finding the current through 10 ohm, we have to consider the resistance value of this entire branch. So that will be 10 plus 2. So Rx will be 10 plus 2 ohms, right? So Rx is equal to 10 plus 2 is equal to 12 ohms. So now we can find the current through the 10 ohm resistance. Let's say IR10. Let's put ohm here. Is equal to, again, total resistance. So RT, which was 0.54. 0.54. RT over Rx, which is 12 ohm here, times IT, which is 55.56. Right. So that is 0.54 over 12 times 55.56. We have 2.5. So 2.5 amperes. That's the current through the 10 ohm resistance and also the 2 ohm resistance, because they're in series. And the current through all series components are the same. Now we have another question. Again, what I just said applies here. So find the current through the 3 ohm resistance. Now this is an entire series circuit. So one common point, again one common point, so it's a series circuit. Now what I just said, the current through all series components is the same. So a single current I will flow through all 3 of them and then back to there. So there's no I5 or I10 or I3. It's all the same. So the current through the 3 ohm resistance will be the current through the entire circuit. So we can just use Ohm's law. We do not need to use the current divider. So by using Ohm's law, we can get I is equal to the total voltage E. So 30 over RT, which is 5 plus 10, 15 plus 3, 18. So 18 ohms is equal to 30 over 18. That's 1.67. 1.67 amperes. Now if you want to prove using the current divider rule that the current through all series components is the same, then we can do that. So let's do I3 ohms, right, is equal to, we need the total resistance on top, so that's 18. Then we need Rx. Now again, remember, for a series circuit or series connection, we use the entire branch. Here there is only one branch, and that is 18. So we cannot use just 3, we have to use the entire branch. So again, we put 18 down here, times IT, 1.67. Now 18 cancels out, so we have 1.67 amperes left for I3, which is the same through I10, I15, is all the same. So current does not divide in series circuits. Current divides only in parallel circuits or parallel connections in the case of mixed circuits.